Okay. Uh, Welcome back on for the third part ng ating discussion sa limits. So in this particular discussion, medyo mabilis lang to. We are going to tawag ito, discuss ano yung function or yung limit as x approaches infinity. So may mga limit kasi sa calculus na ginagamit na ine-explore yung behavior ng mga functions kung yung ating absolute or kung yung ating function or yung x independent variable uh, gets infinitely large or infinitely small. So this limit offers insight into the behavior ng graph. So minsan ang tawag nila dito examining end behavior, or often the limit as x grows infinitely reveals a horizontal asymptote of function. So ayan, yan yung ating uh, pag-uusapan on this third part. Okay? May mga formal and informal ways to examine yung mga limits ng mga ganitong functions, na ganitong limits. Uh, Informally, pwede mo, you may think about what is happening on each part of the function as x increases in magnitude, and pwede mo i-consider how fast each term is growing. Formally speaking, you can sometimes change the form of the given function to determine the limit. So may mga examples tayong pag-usapan dito to shed some light, no? Ah, dito sa mga approaches na to. Okay? Nasagot niyo na ba yung tanong ko kanina? So, again, uulitin ko lang ulit. Ang tanong, can a limit of a function exist as x approaches a given value of domain ng ating constant kahit na walang value yung function na yon at that particular domain? Ang sagot natin dyan is yes. Okay? Pwede tayong makakuha ng limit by finding the y value ng isang function kung saan papunta yung y. Ang term na ginagamit natin is approaching. Kaya siya ginagamit na term approaching kahit na dun sa graph meron tayong hole or hindi siya kasama dun sa function, pwede pa rin tayo makakuha ng limit dun sa point na yon. Okay? Again, uulitin ko that the limit or the existence, no? The existence or non-existence of a value on a particular function has nothing to do with the existence or non-existence of a limit for that particular function. So walang kinalaman kahit pa walang value yung function at a particular number. Pwede tayong makakuha ng limit doon sa uh, value na yun. Okay? So, simulan na natin itong discussion natin sa mga limits that approach as x approaches infinity. No? This limit offers insight into the behavior of the graph of the function way out on the right or left end of its domain. This is sometimes called examining end behavior, and often the limit as x grows infinitely reveals a horizontal asymptote of a function. Right? So, meron tayong mga ganito, no? Mga example dito. Meron tayo ditong limit of 1 over x raised to the n. May parang inverse siya, tapos exponential. As x approaches infinity, equal yan sa value ng 0. No? Pakitandaan, kasi magagamit natin yan. Pag magsasolve na tayo or magsisimplify tayo ng mga functions, magagamit natin tong ano na to, relationship, no? Uh, Another way is to rewrite itong function na nasa loob dahil yan ay 1 over x to the n. Remember, recall lang natin na 1 over x to the n is also equal to x to the negative n. Diba? So, ganyan lang yon. So, i-rewrite natin the limit of this function x to the negative n as x approaches infinity is also equal to 0. Yan. And kung aalisin naman natin yung negative sign dito sa exponent natin, the limit of an exponential function x to the n as x approaches negative infinity, no? Negative infinity ha. Hindi po ito left hand limit, no? Ito ay negative infinity. Okay? So magkaiba yan sa minsan mapapansin nyo left hand, right hand, no? Ito po ay negative infinity na value. So equal din yan sa 0. Okay? So saan natin yan pwedeng gamitin? Mapapansin nyo yan dito. Gagamitin natin yan to solve this particular example on the limits of rational functions. So, let us solve this analytically. No? Meron tayong 4 ways, right? Let us solve this analytically. Kasi pag sinubstitute natin yung infinity dyan, infinity, ang lalabas dyan is 2 times infinity minus 4 times infinity all over 3 times infinity plus 5. So, sa unang tingin, the limit might not exist or masasabi natin infinity, pero this is not the case. This example has a limit. Kung i-graph lang natin yan, no? Analytically, pwede natin gamitin itong ating relationship dito that when we divide this function or expression by x to the n such that magiging denominator yung x to the n, pwede na nating i-evaluate yung ating limit. Di ba? Tama ba? So, our first approach is to divide the expression by yung pinakamataas na power, na may power, no? So, in this case, yung x squared. Okay? So, i-divide pala natin yan sa x squared. Bakit? Kasi ang gusto nating ma-attain is magkaroon tayo ng ganito itsura. No? Kasi pag in-evaluate na natin yung limit ng ganyan na yung itsura ng ating expression, 0 na lang siya. Cancel out na lang. So, in this case, i-rewrite lang natin the limit. We are going to divide all terms, no? All terms. In the expression. Dividing all terms in the expression by x squared, we now have the limit as x approaches infinity of 2x squared over x squared minus 4x divided by x squared all over 3x squared over x squared plus 5 over x squared. No? Ganyan yun, no? Medyo masakit lang dahil marami ng numero or marami ng expression, but madali lang ito, no? Medyo madali-dali pa ito. So, we are going to simplify this expression. Mapapansin natin na dito sa una, mag-cancel out yung x squared. Tama? Yan, mag-cancel out yung x squared. Dito naman, so matitira dyan is the limit as x approaches infinity, ng ating function na natira dito is 2 minus dito naman ang natira is 4 over x dahil ang naiwan ay 2 dito, x. So x na lang yan, nag-cancel yung isa. Tapos sa ilalim, sa denominator, mag-cancel ulit ito, no? We now have 3 plus ito naman 5 over x squared. Wala tayong magawa na dito. Yan na siya. And sabi dun sa theorem, no, sa first presentation natin, we can actually get the limit of this rational function. So by substituting na yung ating value, no, dahil rational function na siya. Therefore, the value of which is substituting 2 minus 4 over yung ating infinity, no? Palitan ko ng pula to para intense. Pula na yan. So ito ay infinity dito, 'di ba? All over 3 plus 5 over infinity. O, di ba? So, pagka ganyan, yung 1 over infinity kasi, equal yan sa 0. No? Tatandaan natin yan. 1 over infinity, equal yan sa 0. Or x to the negative infinity, 0 din yan. No? Okay. Pag nasa ilalim na yung ating infinity, nagiging 0 na siya. Kaya, itong value ng 4 over infinity, magiging 0 na to. No? Kasi ito ring 5 over infinity squared, magiging 0 din yan. No? Kasi habang tumataas at tumataas, nagiging 0 na sila. Therefore, ang naiwan na lang sa atin is yung 2/3. O, di ba? Ibig sabihin, yung limit of this particular function, 2x squared minus 4x all over 3x squared plus 5 as x approaches infinity is equal to 2/3. Hindi siya infinite. Meron tayong limit dyan sa function na yan. Yan ang kagandahan nitong relationship na ito. Pakitandaan, no, na ganyan yung approach pag usually, ganyan yung approach kapag kumukuha tayo ng limit ng isang function as x approaches infinity or negative infinity. Kung negative infinity naman, kailangan ganito yung itsura ng ating function. So, wag nating i-divide, no? Okay? So much for that. Puntahan naman natin yung, so pakitandaan tong example na to, ha. Yan. Meron din tayong mga tinatawag na special limits. Ito magagamit natin to when we are trying to solve yung mga limits na medyo komplikado, no? In this first example, we have the limit of sine x over x as x approaches 0. So, equal yan sa 1. No? And then, the limit as x approaches 0 of 1 minus cosine x all over x, 0 naman yan. Then, the limit as n approaches infinity ng quantity 1 plus 1 over n raised to the n is equal to the Euler's number E. So, ito, pakitandaan. Then, the limit as n approaches 0 naman ng quantity 1 plus 1 over n raised to the 1 over n is also equal to E. Yan yung actually definition ng Euler's number. Okay? So, ano pa? So, we also have here mga special limits na mga value na exponential and logarithmic. So, una, if we have for values of A greater than 1. Mga 1.1, ganun. Tapos 1.2, 1.00001. Yan, no? That is also greater than 1. Pwede to. Pwede natin gamitin itong mga limits na to. Mga relationship. The limit of a to the x as x approaches positive infinity is equal to positive infinity, of course. Kasi nga, a to the infinity is also infinity. Diba? Ganyan siya. Pero, kapag in between ng 0 and 1, so for example, 1 half, mga gitna ba? Fraction. Or let's say 0.531, ganun. Yung nagiging value ng a to the x as x approaches positive infinity, magiging 0. Kasi, yung value ng ating a is a fraction. So let's say 1 half raised to the x. Yung ating x kasi napupunta sa ilalim. Kaya anong nangyari dyan? 1 over 2 to the x. So pag nilagyan natin ng infinity sign dito sa ilalim, pag sinubstitute natin, lumalabas na 1 over infinity, which is equal to 0. Kaya yung limit ng a to the x as x approaches positive infinity for values of a between 0 and 1, ang sagot dyan is 0. Diba? Ganun dito sa mga susunod na limits. Yung limit of a to the x as x approaches negative infinity para sa mga values of a greater than 1, equal yan sa 0. And then the limit of a to the x as x approaches negative infinity pagka in between 0 and 1, nagiging positive infinity yan. So, kailangan pakitandaan nyo lang itong mga ito. No? And then, the limit of the logarithmic of the log of x base a as x approaches positive infinity dito, positive infinity rin yan. Diba? Tatandaan nyo lang yung graph ng log. Pero, kapag in between 0 and 1 yung ating a, yung ating base, so for example, the log of x base 0.5, ganyan. So, yung limit niyan as x approaches positive infinity will be negative infinity naman. No? And then, pag 0 naman yung ating domain, the limit of logarithm of x base a, pag yung a natin is greater than 1, and yung x natin is approaching 0, equal yan sa negative infinity. Then, kapag yung ating value ng a is between 0 and 1, say log of x base 0.5, as x approaches 0, ang value niyan is positive infinity. No? So, pakitandaan kasi gagamitin natin yan sa pag-solve ng mga limits and differentiation. No? Yung mga limits na yan. Okay? So, I think that's the end of our first or second presentation lecture on differential calculus. In particular, limits. We studied the definition of limits. We touched on theorems dun sa first part. And then we had a few examples to prove that limits do exist or do not exist. Ano pa ba? Sa second part naman, we explored yung mga one-sided limits and the general limits. So may mga example tayo dyan. Plus, there are 4 ways on determining a limit. No? Diniscuss din natin yan isa-isa. And then dito naman sa third part, we touch on the limits as x approaches infinity. Pag mga sobrang tataas na. Okay? Hiniwalay ko lang siya para pwede niyong balikan yung mga identities or yung mga special limits. Okay? We also discussed yung mga special limits. So after this presentation, meron kayong problem solving or mga exercises that you have to answer This will test your understanding ng concept ng limits. So, take time to answer yung mga yan. And kung meron kayong questions, post nyo lang dun sa ating LMS or PM nyo na lang ako. You can also comment on our YouTube video. No? With that, I would say maraming salamat and keep safe. See you on the next meeting. See you on the synchronous classes. Okay, maraming salamat.